Hello and welcome to my channel, where in this series I take you through past VCAA Maths Methods exam questions and provide you with my full work solutions. Today's video will be going through multiple choice questions 15 and 16 from the 2020 exam 2 VCAA exam. As always, I'll invite you guys to attempt these questions first before I jump into the solutions. Great, so starting with question 15, part of the graph of a function f where a is greater than 0 is shown below. I've got this nice graph. It's a bit of a hybrid function, I guess, with the cusp at x is equal to 0. The average value of the function f over the interval minus 2a to a, inclusive of both points, is. So we're going to start off this question by using the average value formula. So we know the average value in general would be equal to 1 over b minus a over the integral between b on a of a function f of x dx, where b marks the right side endpoint and a is the left side endpoint. So it sort of spans the region from a to b. Great, so I think where people probably get confused next is the fact that this is a hybrid function. Obviously it's discontinuous. So what we can do is we can break it up at that point where x is equal to 0. So going to maybe just zoom out so it's a little bit easier to see. We're now going to say this average will be yes. So we can plug in the value of b and a. So b being the upper point, which is actually a little bit confusing, minus, and a being the left end point is minus 2a. So a minus 2a like that. The integral between two different functions. So let's break this up into two different integrals then. So we've got we want to go from minus 2a up to 0, minus 2a up to 0 of this first function. So I'll just call it f1 of x dx. And then we're going to have the second part. So this would be from 0 up to that point a there. 0a of f, we'll call that fx2 dx. Great. So obviously we'll need to work out what this function f1 of x is and f2 of x, and that should be relatively straightforward. If we look at this function f1 of x, we can see that the gradient is going, would be, so we're going down by 3 and across by 2. So therefore the gradient would be minus 3a on on 2a. And 2a x, and the y-intercept value is minus a. So therefore this function is actually minus 3 on 2x minus a. And we're going to have this second function, f2 of x. We're going up by 2 and 2a, I should say, and across by a. So we've got 2a on a, and again that y-intercept is minus a. So that makes it nice and easy. Cancelling out the a's there, we've got 2x minus a. So from here, we're going to take this function, sub it into there, and take this function, and plug that into there, and we'll be able to get our answer. So I'll just write that out again so it's nice and clear. So this average will be equal to 1 over a minus minus, so this is 1 on 3a. Then we're going to have our two integrals between 0 and minus 2a of f1 of x, which is minus 3 on 2x minus a dx, plus this second integral, which is a to 0 of the second function, 2x minus a dx, just like that. Cool. If you do that, plug all that equation exactly as is into your calculator, you should get the result a on 3 as the final answer, which ends up being b, I believe, over here. So a little bit lengthy, the various aspects involved. You need to work out the equation of two straight lines in terms of this unknown a. It's testing your ability to, your knowledge of the average formula function. and dealing with additional unknowns, because obviously your answer is not an exact value, it's in terms of another unknown there. Great, so moving on to question 16, I'll just zoom in a little bit. It reads, a right angled triangle OBC, so that's this triangle here, is formed using a horizontal axis and the point C, which has coordinates m and 9 minus m squared, where m is an element between 0 and 3. On the parabola, y is equal to 9 minus x squared, as is shown below. The maximum area of the triangle OBC is. So we've got this parabola. We know you could solve for the x-intercepts, and you'd see that this point here ends up being 3, 0. And this is what they're sort of stating by putting that bound on the variable m. So C can slide essentially anywhere along here and anywhere along here, since it's just in terms of this variable m. So what the question's asking us, where would C actually have to be to make this grayed out area as large as possible? And then what is the maximum area? What would that area be? So how we go about solving this? Well, we'll start off with the area of a triangle, since that's the shape that we've been given. So we know the area of a triangle would be half base height, where the base is just from the origin to point B, which we know would be 0 up to m. So this has a base width of m, and the height is just the y value of the point C, which would be 9 minus m squared. So in general, this expression here gives us what the area of this triangle would be. Now, in terms of maximizing this area, hopefully you guys hear the word maximum and you think of stationary points. So this maximum can be found when the derivative of the area with respect to m is equal to 0. So on our calcs, what we can do is we can solve for the derivative of this above expression, equate that with 0, and that should give us a point m. So we want dm of half m 9 minus m squared. So this here is that derivative of function a. So that's function a, or the area, and this is the derivative of that. Equating that with 0, and then solving for m on the calculator. Now this provides us with two solutions. We've got m is equal to plus or minus the square root of 3, but we know since m is between 0 and 3, we would just be using the positive square root, and we can sort of get rid of that minus. Now we're almost there. The last part of this question, so reading what we're looking to find again, is the maximum area. So we know when the maximum area occurs, but not the maximum area itself. So all that we have left to do is sub in the square root of 3 into the area function. So this is the area at point m is equal to 3, would be half square root of 3, 9 minus square root of 3 all squared. And we might as well just finish off this bit by hand. Half root 3, root 3 squared would be 3, 9 minus 3 is 6. So therefore we're going to have 6 divided by 2 is 3, so the area would be 3 root 3. Cool, so hopefully that's one of the options, and it looks like it is option D. So not too bad if you know the right approach for that one. So if we look at the examiner's report, jump up to question 15, we can see that B only had 32% of students answer that correctly, and there's some comments there reiterating what the formula for the average value is, and they're subbing in between A and 2A, sort of like we had in this step here. And then they've also got, as their last step of workings, what we had prior to entering into the calculator. So I guess their comments there indicate that you will need to do a large part of this by hand, the setting up of the expression, and then the actual computational side of things you can just do on the calc. We sort of worked out these straight lines by hand, but you can also use your calculator to assist you with that as well. That's a pretty important step to get right. Question 16 was answered a lot better with 53%, and there's no comments for that one, but hopefully that's nice and clear. This type of problem comes up quite a lot, so hopefully you guys are familiar with it and you've had a bit of practice already. All right, we'll leave it there for this one. Hopefully you guys got something out of the video. Please leave the video a thumbs up and subscribe if you haven't already. I appreciate if you guys share my content with friends or classmates. Lastly, I do take video requests. So if you guys want me to answer a specific question on the channel, then please send me an email at yourmathquestions@gmail.com. Thanks for watching, guys. I'll see you in the next one.